Have you ever just stood somewhere, looked out at a landscape, mountains, rivers, forests, the whole shebang, and wondered how a scientist can see a whole story in what looks like just chaos? Well, today we're going to break down that exact process. We're diving right into the Geographer's Toolkit to learn how they use science to read the world around us. Okay, just take a look at this scene. It's beautiful, right? But wow, it is incredibly complex. You've got these massive mountains way in the back, these huge sand dunes right up front, different kinds of forests, some grassy areas. So here's the big question. How does a scientist even begin to understand a place like this? I mean, where do you possibly start? Well, it all starts with the number one most fundamental tool of any science: careful, systematic observation. A geographer learns to look at the world with what you could call a geographer's gaze. It's a really specific, disciplined way of seeing things. And this right here is the golden rule. The absolute first step is to just observe. That's it. You're basically a data gathering machine. You list what you see, and trust me, this is the hard part, you have to fight that urge to explain why. No interpretations, no theories, not yet. That stuff comes later. For now, it's just the facts. So let's actually try this out. Looking at our landscape, what do we see? Well, there are mountains, and they've got a pretty clear tree line with just barren rock up top. Okay. In the foreground, we've got these big, light-colored sand dunes. We can also see there are different kinds of forests at different heights on the mountain. Then there are some flat, grassy areas, maybe with a few shrubs, and yep, a blue sky with some puffy white clouds. That's it. Simple, direct observations. No whys allowed just yet. So now that we have our list of raw facts, our brains immediately start buzzing with questions, right? Just natural. Why do the trees stop at a certain height? How did sand dunes get right next to a bunch of mountains? See? These observations just naturally lead to questions, and that curiosity, well, that's the engine that drives the whole scientific method. And this whole process, from seeing something to wondering about it, that's what we formalize in the scientific method. You make an observation, and it sparks a question. That question then leads you to come up with a possible explanation, a really good educated guess, and we call that a hypothesis. And the most important part, that hypothesis has to be something you can actually test. Now, this is a fantastic example because it makes the whole process so clear. Let's just walk through it. Step 1, the observation. There's gasoline in the groundwater. Yikes. Step 2, the question. Did it leak from that buried tank nearby? Step 3, the hypothesis. The tank is the cause. Now, here's the really crucial part, the prediction in step 4. If the tank is the cause, then we should find a leak when we check it out. And finally, step 5, you test it. You collect the data, you check the tank, and no leak. Now, that might sound like a failure, but it's not. It's actually a success because you just proved your hypothesis was wrong. You can eliminate that possibility and move on to better questions. That right there is science in action. All right, so we've got a method for asking and testing our questions. But how do geographers keep track of all the countless moving parts in a landscape? Well, they learn to think in systems. Almost everything in nature is what we call an open system. And that just means it's not sealed off from the world. It's constantly interacting with its environment. Energy, matter, and information are always flowing in and out. And this is a brilliant way to show how that concept works at different scales. Think about the entire planet Earth. It's an open system for energy, right? Sunlight comes in, heat radiates out. But for matter, it's mostly closed. Now compare that to a single tree. That tree is a completely open system. It's constantly swapping water, nutrients, gases, and energy with everything around it. And these systems aren't just sitting there, they're super dynamic. They have inputs like sunlight or rain. They have responses like a river flooding or a plant growing. And most importantly, they have feedbacks. This is where the result of some process actually circles back around to influence the original process. Okay, understanding feedbacks is absolutely critical. And here we see the two main kinds. A positive feedback is like a snowball effect. It amplifies the original change. The example here is perfect. As bright, shiny ice melts, it uncovers darker ocean water. That dark water absorbs more sun, which warms it up even more, which causes, you guessed it, more ice to melt. It's an accelerating cycle. Then you have negative feedback, which is more of a balancing act. It's stabilizing things. For instance, warmer water leads to more evaporation, which makes more clouds, and those clouds can block sunlight, helping to cool the water back down, fighting that initial warming. So we've gathered our observations, we've asked our questions, and we've started thinking in systems. Now comes the really cool part, putting it all together to tell the story of the landscape. Because that's really the end goal here. A geographer isn't just making a list of disconnected facts. They are putting together a narrative, a scientific story that explains how and why that landscape looks the way it does. And this, right here, is one of the most powerful ways to do it, a concept sketch. This is so much more than just a pretty picture. It's a visual summary of the entire scientific process. It takes all our observations and ideas and actually connects them, showing the processes and relationships at play. It's basically a hypothesis on paper. And if we follow the logic on this sketch, we can see how it all fits together. Those barren peaks, well, they're above the tree line because it's just too cold up there for trees to grow. The sand dunes, they're there because the sand is unstable, dry, and doesn't have the nutrients for much else. The different types of forests are all organized by elevation, and that grassy area can thrive because the ground is more stable and has better soil. Suddenly, every observation has its place in the story. Now, this incredible storytelling process, observe, question, analyze, it doesn't just work for one little valley. Geographers can scale this exact same way of thinking up to read the story of our entire planet. Of course, to work on a global scale, you need a grid system. The first piece of that is latitude. It's just the angle that tells you how far north or south of the equator you are, going from 0 degrees at the equator up to 90 degrees at the poles. And the other half of that puzzle is longitude. This measures how far east or west you are from an imaginary starting line called the prime meridian, which runs through Greenwich, England. Put them together, and latitude and longitude give every single spot on Earth a unique address. So here's the big takeaway. It doesn't matter if you're studying the tiny details of a single mountainside or analyzing massive global climate patterns. The fundamental way of thinking is exactly the same. You observe without jumping to conclusions, you ask smart questions, and you analyze how all the systems are connected to tell a scientific story. So now you have the tools. The next time you look outside, don't just see a street or some trees. See a landscape. Try on your new geographer's gaze. Observe. Question. What story is the world outside your window trying to tell you?